Up next on the Quickfire Talks is Christopher Richins, the founder and CEO of RBC Signals, which provides global satellite communication infrastructure as a service. He began his career in radio frequency communication engineer at Boeing Sea Launch, where he supported multiple launch campaigns from the ship-based Equatorial launch site. So up next, Christopher. And I see you're mic'd up. So,
is it working?
Here you go.
Thanks. Yay. I am really excited to be talking to you today about RBC Signals, and I think this conference is just so much fun because it represents a passion of mine. And the last panel talked a little bit about history and what is NewSpace, and I'll get into that, at least from my perspective, here in just a moment. But for me, where this starts is, we've heard it often mentioned that data is the new oil. These are all pulled from the web, pictures of articles that are being written about how information is the new currency. And I think space is so amazing because it represents a multi-billion-dollar repository of information that needs to be refined, extracted, moved, processed, sold, distributed. All of those, the analog is quite close. The similarities between oil and data, hopefully data is a little cleaner, but it's a strong similarity. And the easiest way to explain what we do at RBC Signals is to say that RBC Signals provides the pipelines that move data between space and the ground. And looking forward to talking about that a little bit more today. This hieroglyphics tablet represents the fact that I'm going to talk a little bit about history for a moment. Because there are students here, I want to talk a little bit about my personal history and why I started RBC Signals and how that might be relevant to some of the conversations that are happening today at this conference. This year is special to me because it's the 20-year anniversary of when I was bitten by the space bug. It was 20 years ago this year that I was sitting in an apartment in Ukraine and found out about this company, Sea Launch, that takes Russian and Ukrainian rockets, puts them on a ship, sails down to the equator, launches huge satellites into space. And up until that point, I was just going to be a business major. In fact, I wanted to be a geneticist, but when I got to college, all the genetics classes were full by the upperclassmen, so I decided to take computer classes and ended up being a business major. And I was 3 semesters from finishing my business degree when I heard about this space company, the Sea Launch. And I thought that was so cool to be with Russian and Ukrainian rocket scientists on Norwegian ships going down and launching stuff into space. So I called them up on the phone and I said, I would do anything to work for you. What do I need to do? And they said, well, we need communications engineers. We need RF technology. I had no idea what that even meant. But I changed my major that day, and I became an electrical engineer. And it took me 3.5 years instead of 3 semesters. But I knew not just that I wanted to work at a company like Sea Launch. That was cool. But the coolest thing about Sea Launch was the fact that it was a multinational company pursuing objectives in space. And I thought, what better way to bring the world together than to be able to do it from space, where as you're looking down from space, I used to say that you couldn't see borders. And then one of my friends who's been to space said, actually you can. You can see very clearly, especially at night, the differences between developed countries and undeveloped countries. But let's say that from space, it's easier to see how we're one big family. And I thought that when countries and companies work together, what a powerful thing that is. And so 20 years ago this year is when I decided that someday I would run a multinational space company to be able to help make the world a better place and to help bring countries together. So with that, let's move on and let's talk a little bit about what RBC Signals does. So RBC Signals provides those pipelines between space and the ground. And well, what's the big deal? Why is that so hard? Well, what you're looking at here, this is a picture of the path that a satellite in a polar orbit will travel in 24 hours. And I'll show you what another orbit looks like in just a second. But when you look at this picture, one of the things that should jump out to you is that a satellite covers a lot of ground in 24 hours. A satellite will orbit the Earth every 90 minutes. And that means it will be in view of a communication station on the ground for only a few minutes every time that it goes around the world. And so for a communication station that's on the ground, let's look at another picture. This is a picture of a satellite in the International Space Station's orbit, so or an orbit that's inclined at 56.1 or 2 degrees there. What you see in the top corner, that green circle, that's if we had a ground station sitting up on the roof of this building. How much of the sky could that ground station see? And how many minutes per day would you be able to communicate with this satellite if you had that ground station up there? And it's less than an hour a day that you would be able to communicate with your ground station. So 23 hours and change in the day, you would have no contact whatsoever with your satellite if you only had one ground station on our building. Because these satellites need to be within line of sight of your antenna on the ground to be able to communicate with it. So when we think about the pipelines and the billions of dollars that are going to be generated because of the data coming from space, how are we going to get that data down to the ground if it's so difficult to communicate? So what you need to do is you need to have a global network of infrastructure, not just so that you can see your satellite more often, but it's also about how long does it take between opportunities to get your data down? How old is the data when it comes down? If you're only seeing your satellite once every few hours, it's going to be difficult to have that fresh data that you want. So if you want fresh data, or if you want to be able to move data, a lot of data, if you've got a big repository that you're collecting up in space, you're generating this awesome SAR data that we've talked about or these other things, you need to have big pipes to bring that data down, and you need to have lots of opportunities to be bringing that down. And so that was the problem that I saw before I started RBC Signals. I was working at a satellite company. It was one of these NewSpace companies that was not backed by the government. It was a commercial company, and we needed to move a lot of data. And so I started looking at what were the options to me to move data from space to the ground. And the only options that were out there were use government-owned systems that had been serving government and DoD interests for 50 years, where the prices were just astronomical and in no way could support a commercial company and the business models that we had. Or I could spend tens of millions of dollars and go out and build my own global network of ground stations so that I could bring data down from space. But the problem is you would spend these tens of millions of dollars. Let's say we built this beautiful antenna on the roof of the hotel. It's overlooking the water. It's really nice. But it's only being used for less than an hour a day. And so 23 hours a day, it's sitting there doing nothing. And what a horribly inefficient use of capital and assets. And I realized that any company that wants to put anything into space is going to have this exact same problem. They're going to have a choice between really overpriced services, or they're going to have to spend a lot of money and a lot of time and a lot of regulatory effort to be able to go and build this global network of ground stations. So we wanted to make that job easier. This is a quick note to say why these ground stations are important. This is some recent news. Peter and Rocket Lab were getting ready to launch this past week, and they ended up slipping a day. Why? It wasn't because the rocket wasn't ready. It was because one of their antennas wasn't ready to be able to support the mission. And as he says here, it's required for that data stream. And it's just another indicator that these ground stations, these antennas, the space-to-Earth communication, it's important. So let me talk a little bit about the products and services that RBC Signals brings to solve some of these problems. So we have solutions that are flexible, simple, in terms of the pricing model, easy to use in terms of the API-based scheduling, and it's global. This map is an actual map of the coverage of our antennas. We've got over 60 antennas all over the world. You'll see we're really excited about a recent deal that we signed with ISRO, the Indian Space Agency, through their commercial arm at Antrix. And our partners in China and in Europe. And don't despair that you see a lack of coverage in South America or in the southern hemisphere. That's coming. But what we see is the ability to communicate with your satellite often so that you're able to bring that data down flexibly, affordably, and in the volumes and with the freshness that you're going to want to be able to support your commercial business needs. And you're able to pay for that on a pay-as-you-go basis. So instead of having to have a huge capital expense and a huge maintenance and OpEx complexity, you're able to come and use exactly what you need from RBC Signals as a service. So briefly, I'll say that we are able to provide core services, and that's what we call our dedicated antennas. So it's just like you had gone and built an antenna yourself. You get guaranteed access to it, you get unlimited use of it, and you pay just a flat monthly fee for that antenna. As many spacecraft as you have, and the more spacecraft you have flying over that antenna, the more value you're able to get for that flat rate per antenna. And then there's the network services, where we're able to provide services across our partner network on a first-come, first-served basis, where you're paying a subscription price for the amount of services that you're using on a monthly basis. And this gives a lot of flexibility to our customers, where we provide these hybrid approaches, where we say, get some of your assets, have them be dedicated so you can use them when you need them, but then let our flexible capacity help you in different phases of your mission where it's important. One of the things that our customers often tell us is, oh, we're going to use you, but just for 1 or 2 passes per day. And what we find out is as soon as they get into space, they immediately come to us and say, we need every pass you can give us all the communication you can. And it's because when you launch a satellite into space, there's just a lot of work. And it's really frustrating for your teams to sit there and wait for hours for the next communication window, especially when that communication window is so short. It can be less than 10 minutes per pass and then your hours in between. So we're able to provide that flexible capacity through our network to be able to provide additional communication capability. And then we've got our support services. A lot of companies don't have crack satellite engineering communications teams like we do. So we're able to do a full communications architecture work for you, where we start from the requirements that your customers have and derive from that, what are the radios you should be using? What are the spectrum choices that you should be making? What are the what hardware and ground station locations should you be doing? And then once you've decided, if you decide you want to build your own ground stations, we've got a whole field operations team that can go out, build that ground station for you, find the sites, do the site surveys, make sure that the infrastructure is there and ready to go. And then we provide regulatory support, which is one of the biggest problems that our customers face. Which spectrum should they be using? Where can they get a license? How can they get that license? It seems easy, right? You go to the FCC, it's $60, you put in your application. The devil is in the details, and we're able to provide that support both within the US and outside. So quickly, the milestones that we've reached. Founded the company 3 years ago. Since then, we've raised $2.5 million in VC funding, and we've signed global agreements with over 25 partners for those 60 antennas around the world. We've built some of our own antennas, with the first ones coming online just a year ago. And currently, we're handling about a run rate of 9,400 passes a year, and that number is constantly ramping. So what's next for RBC Signals and for the services that we provide? And it's really about the intelligent edge and the software-defined ground station. So many of you have probably heard about software-defined radios, and RBC Signals is going beyond that. One of the paradigms that's really difficult to grasp is that you see a beautiful antenna like this. It's gorgeous, it's iconic. How many satellites do you think can communicate with a beautiful antenna like this? The answer is one. One satellite per one antenna at a time. And that is a paradigm that has existed from the beginning of the space age. Because of the accurate pointing requirements that are required, these antennas have to track the satellites as they fly, and it's one antenna to one satellite. So if you're a company like Planet Labs, and you are flying a constellation of over 100 satellites, you can't just have one antenna at a ground station. You have to have many antennas to be able to talk to the many satellites that are flying simultaneously over your site. And that's a paradigm that just doesn't make any sense to us. But the costs to solve that just really haven't come together. And so even companies like OneWeb, when you look at the designs that they're proposing, they might have dozens of parabolic dish antennas going onto a single field to be able to support the thousands of satellites that they're going to be putting up into space. So RBC Signals is working on this with partners to be able to develop phased array antenna technology that can communicate with multiple satellites using one array. So you've got multi-beam technology where we're able to get rid of these big mechanical systems that are really driving the cost and complexity, both in terms of the capital deployed and the maintenance, and be able to have these phased array antenna technologies that can be scaled together in arrays of arrays to be able to do anything from low Earth orbit communication, geostationary communication. Get enough of them together, you could even do deep space lunar communication. So there are great things that are coming on here. And the technology that we're developing is modular, it's configurable, so that these arrays can be very flexibly adapted to a lot of different installation and spacecraft requirements. And then the last thing that I'll talk about in terms of this intelligent edge is, as we think about this pipeline of data that's going out into space, and we think about these petabytes of data that's coming down, a lot of people don't realize that one of the key costs over the lifetime of a mission of a spacecraft is actually going to be spent on the ground, and it's how you handle that data. And actually backhaul very quickly becomes one of the key drivers of expense. So if you're downlinking all of your data, let's say that you've got a fiber optic connection, you're able to buzz that stuff down at 10 gigabits per second. Once it's down on the ground, it's very expensive then to move that data from wherever it came down back to your central servers for storage and for processing. And so the RBC Signals Intelligent Edge provides virtual machines and storage and compute capacity at the edge, so that you can bring your data down, leave your data at the edge, process it so that the very important data, the high priority data, can be processed and sent to customers. But then the data can just sit there until it's needed, like a content delivery network where it's just waiting. The metadata has been streamed back, so you know where your data is distributed around the world. And then as it's needed by your customers, it can come and be sent to them. And we believe that it's these intelligent edge ground stations of the future, the software-defined ground station, that really enable us to unlock the capacity that the technologies that are being launched into space, they can realize. And we're very proud to be doing that as RBC Signals, and I'll look forward to any questions that you may have about our services after the break. Thank you.